So, hi everyone. I really hope that you enjoyed watching back my talk I gave a few weeks ago now on the hunt for habitable worlds and giving you a flavor of the types of planets that we're finding and how we're kind of classifying them based on what we think life in the universe needs as habitable conditions. So it's my great pleasure to present Dr. Erik Persson, who's with me here on the Zoom. Erik is a philosopher at the University of Lund, and he got his PhD in 2008 on a thesis looking at different theories for assigning value and moral status to species. And Erik's expertise is really on ethics, and ethics applied to a lot of the concerns and things that people are very worried about in the earth at the moment. So things like biodiversity, climate change, artificial intelligence, and also space exploration as well. So I'm going to pass over now to Erik to tell us a little bit about his thoughts about the hunt for habitable worlds and the general question on, is there life out there in the universe? So Erik, over to you.
Thanks, Catherine. Yes, it was a really interesting presentation. Thanks a lot for that. Um, First, I want to say, please excuse my throat. I have recovered from a cold. I hope it will not be too disturbing. Uh, yeah, so there are lots of interesting science in presentation, but there are also lots of philosophically interesting things. Like you're asking, are we alone in the universe? Which is, of course, a very interesting and very ancient philosophical question of really profound existential proportions. So, in a way, what we're doing now and what you and your colleagues are doing now is to um, provide empirical data to help answer this question of really philosophical interest. So in a way, this question of are we alone in the universe is to a large extent an empirical question, which you are working on. But there are also, I would say, some philosophical assumptions that one have to make and some philosophical questions one need to answer in order to like make sense of the empirical questions and the empirical results. So I'm thinking of, for instance, the question, what is it we're looking for, right?
Mhm,
What is life? We're looking for extraterrestrial life, but what is that?
mhm,
And that may be surprising to some that there is really no generally accepted definition of life. I don't think everyone knows what life is. And in a way, like in our everyday life, most of us can say whether something is alive or not. Or like you, Catherine, is alive, but the computer here is not.
mhm,
But and in biology, normal biology, it's usually not a big issue because biologists tend to look at things that we know very well are alive, animals and plants and stuff. But for astrobiology, it's different because it's kind of the essence of astrobiology is to study not just living things. We haven't really found any extraterrestrial living things yet, but to understand the borders of life, right? So it's per definition a matter of looking for the borders of life. And that means there's this question of what is life, what is the definition of life is extra important in astrobiology. We need to know if we study like the emergence of life, it's important to be able to draw the line between where is it just a matter of chemical evolution and when are we talking about biological evolution. But also if we are looking for life on other worlds, as you were talking about,
mhm,
Catherine, we need to know what we're looking for. We need to send the right instruments and make the right um, experiments and make the right interpretations. And we need to know if we found it or not. And to do that, we need some kind of agreed upon idea of what life is. And I don't have the answer for this, of course, but this is an ongoing quest that I think is working in close relation to astrobiology, where philosophy and empirical astrobiology are very closely connected. Um, so this is a typical example of this that I think is really interesting, where philosophy can contribute to astrobiology and astrobiology can contribute to philosophy. And also, I think when we talk about astrobiology and the search for life, um, this also age-old philosophical question of evidence turns up, because this is really hard. What kind of evidence do we need to say that we have found life? There have been, we all know about these examples of um, claims that have turned out to be um, unfounded in the end. Um, and that kind of pushes this question, what kind of evidence do we really need? Carl Sagan used to say, extraordinary claims need extraordinary evidence. And that, of course, the question there is, first of all, is finding of extraterrestrial life, is that an extraordinary claim? And also, what does extraordinary evidence mean? So what kind of evidence do we need? I mean, it would be great if we land on a planet where we find like an ecosystem with easily recognized Earth-like animals and plants waving to us, or if they land here with their flying saucers and come out and introduce themselves. Great, but that's probably not how it will happen. And that's not how you, Catherine, and your colleagues are looking for life. You're looking for, as you mentioned, biosignatures. And the evidential value of particular biosignatures is really hard. So what does it take to be a biosignature, and how do you quantify the evidential value of it? That's, I think, a super interesting philosophical question. As usual, in philosophy, I don't have the definite answer. That's the problem with philosophy. You can't just go into a lab, set up an experiment, and get a result. Right? So it's hard, but it's very important for science, but I think maybe especially for astrobiology, where we are literally moving among uh, the edges. Um, so that's another question that it would be fun to discuss. Um, and then, of course, when you find something, there are new questions depending on what you find. If you find something, how will that affect us? Probably that depends on what you find and how you find it and where you find it. I guess that something that we can interact with will be much more mind-blowing than something we cannot. If we find like some biosignature in the form of some particular gas in the atmosphere of an exoplanet that we can't explain in any other way than with life, and we find maybe several of these in the same atmosphere, and maybe we need to draw the conclusion that yeah, there is life, but there's nothing we can interact with. And I guess the reaction among the general public will probably not be overwhelming. It will be a great discovery. It will be sure to get a Nobel Prize, and it will be. You would probably have a lot of interviews to do for a while, but then people will go back to the normal lives. But if it's something we can interact with, I guess it will be a totally different thing. If there will be something in our solar system that actually moves around, if you find something in the ocean world of Europa that swims around, and we can study with cameras and see how they move and interact. That would be a completely different thing. And of course, if we receive a signal that we can interpret and send messages back and forth. But then, of course, it depends on how long it would take, right? So if we receive a message, there will be lots of interesting discussions about should we answer, could be dangerous. And in that case, what should we answer? And who should have the right to answer? It's a very important ethical question. Who should have the right to speak for humanity? And of course, if they are close enough to, so we can have a conversation, that would be amazing. If they are very far away, it will take maybe generations to get the answer. It could be that the interest will cool down, but it could also be that this will feed lots of speculations, maybe a almost religious movement, people waiting for the second coming, not the second coming of Christ, but the second coming of the message from this civilization. And there will be lots of speculations and maybe conflicts among humans what this answer will be, and so on. That could be interesting too. And of course, if you don't find anything, what does that mean? And again, we could ask about what kind of evidence do we need to conclude that we are alone in the universe? It sounds like just the opposite side of the coin of the question of evidence that there is life. But philosophically speaking, it's a completely different question with a different way of thinking and different kinds of evidence. How do you show that there's no life? How many like failed observations or missions do you need before you give up? And what kind of, probably you need to have a lot of high quality studies to draw that conclusion. Or maybe we will never draw that conclusion because the universe is so huge and it's a really important question, and we will never stop looking. But it may be that if we're talking about a particular celestial body, if you're talking about Mars, for instance, and there are lots of interests in sending humans to Mars, colonizing Mars, and there will probably in the future be some kind of serious discussions. When is it time that you guys, the scientists, hand over Mars to the exploiters? So there will be a serious discussion when is there enough evidence that Mars is uninhabited. This is a really important question, but it's not an empirical question. The empirical science collects the data, but the question of when we have enough evidence to be certain for a particular purpose, that's basically a philosophical question, and there's no clear answer to it. But it will, I foresee that there will be a conflict about this probably sooner than later. So yes, and again, if we don't find anything, if we decide that no, that we are alone in the universe, what does that mean, really? Does that I'm sorry, does that mean that we should take extra good care of the life we know? And will it help? Today we know that life on Earth has a lot of facing a lot of human-made problems, but even though we know that, we don't seem to be sufficiently motivated to do anything about it. So will it make a difference if we find out that it's the only life in the universe? Or will people some of us will be terrified, but the people who have the most influence will maybe go on as usual? Will it help? And also, create questions like, should we try to seed other planets, either like with humans or maybe with more primordial life, and see how it evolves? If life is a good thing, then maybe we have a moral duty to see the universe, if we know that we are alone. Some people want to do that even if we don't know that we are alone. But that's, to me, that sounds is not necessarily a good idea. I mean, it could cause havoc among existing ecosystems. And if some very powerful extraterrestrial civilization notice that these Earthlings start um, sending life to other planets, maybe they decide that it's better to get rid of us while there is time. So, yeah, well, these are just some examples of super interesting philosophical questions that I was thinking of when I heard your presentation. Maybe you want to react to some.
Yeah, I wrote quite a bit down while you were talking there, and mainly kind of, I think, summarizing or paraphrasing when you did raise a question. And one of the first things, I wrote down is, what is life? Because,
Mm,
like you say, I think that, you know, empirically, one might naively think that we have a very good definition of it, but it's very true that we still have no idea, really, how life arose on Earth. We can, trace life back, I think, is it the last universal common ancestor? And beyond that, we don't know. It's a big gray area between chemistry and biology. And I think that this is certainly, like you said, you mentioned astrobiology a lot. That's really where I feel like astrobiology from an experimental point of view, although not creating life in the lab because, well, we don't know how to do it, but at least trying to figure out how we go from simple chemical processes to complex biological processes, I think is a really interesting one. Again, kind of from the experimental empirical point of view. And then you talked a little bit about the borders of life. And again, that kind of, when you said about that, I was thinking about things like extremophiles, so it seems that anywhere we look on Earth, we seem to find life. We find these creatures that can exist at very high temperatures, so well beyond the temperature that proteins are denatured. And we think proteins are important for life, for regulating, very important biological processes in our bodies. We find creatures living almost, at high pressures in at the bottom of the ocean, which is likely one of the most inhospitable places on Earth, and also, at the edges of volcanoes. I remember I've been to Iceland a couple of times, and they have an amazing kind of ecological system where, again, around the hot springs that are very acidic, very sulfuric, you still see, little creatures. So we tend to think that life on Earth likes this nice environment that, yeah, humans generally live in, but that's not true for all life on Earth. Some life on Earth lives in very, very extreme environments. And I suppose part of me feels a little bit like that's then hope, or, maybe our boundaries of life are too narrow. You see what I mean? And
yes,
I think also, I mean, they've brought samples up to the International Space Station. And again, I think that's a very important place to try to do empirical measurements of the limits of life. Of course, we're doing that on humans, which is another ethical question. We have people, I think, the last astronauts that came back down, they'd been in space for a lot longer than they'd intended. And I think there's more trapped up there because they need to be
yes,
sure that the vehicle to bring them home is safe to do so. So, there's a lot of interesting, kind of experiments going on there to see what just living in low gravity is like for humans. But they also have lots of biological samples up there, including bacteria and these little tardigrades that seem to be very happy to just float around in space. And technically, they are alive. They kind of fit within our definition. So I think, probably when you were talking about borders of life, I was thinking, well, if you really think about where life is and where we've put life, you know, we put people in space and they survived, right? So of course we've created the environment for them within which to do that. But again, that kind of makes me optimistic, maybe, that our definition might be very narrow and we're maybe not exploring all options.
True. We have, you mentioned Luca before, and that's
Yeah.
in a way there's a problem when we define
Mm,
life that all life on Earth is related, which means that the properties that we identify with life on Earth, we don't know if they are typical for life,
mhm,
or maybe it's just that all life on Earth have them because we are all related, but life otherwhere would be very different. But at the same time, one would think that we need to have something in common,
mhm.
otherwise we will not both be life. But
Yeah.
what that is very hard, and
Mhm,
life is evolving, which means
mhm,
life is like a moving target. It's
mhm,
really difficult to pinpoint what is it that all life has in common.
mhm,
And people have of focusing different disciplines, even focus on different things. Chemists like to focus on the material basis for life, while others tend to focus on the functions that life perform. Uh,
mhm,
Physicists like to uh, see life as information, for instance, or as something that can temporarily withstand the second law of thermodynamics.
mhm.
Um, I think in many cases um, we need more interdisciplinary uh, cooperation here when we
Yeah,
study
that's
life, and
true.
also eventually we need to find extraterrestrial life
Mhm.
to have more than one sample.
I think I absolutely agree with that. I mean, you know, we are, you know, again, from the astronomy, astrophysics point of view, we rely a lot on remote sensing, but if we remote sense something, we still have to have some kind of interpretation of that that can always be open to interpretation, right? You can never say that one model is the only model of something. And I think about, you know, if we were, you know, a planet that was, you know, orbiting around Proxima Centauri b, which is one of our close neighbor stars, and we were able to look at the Earth, would we be able to tell that the Earth had life on it? Even with
That's a
all
good
of
question.
all of the technology that we have just transplanted elsewhere. And I'm not sure we if we just were, you know, had the tools and technology we had today, if we could answer that question, which I think is
Mm,
interesting. Um,
that's a good point, and that's tell us that we still have a lot to do in the search
Yeah,
for
and I
life as
think,
well.
you know, one of the things that I thought was very interesting when we were talking about Mars, because I think the solar system is still our best chance to tangibly, you know, have our hands on something, like you said. Otherwise, it is just signals, it's light signals that we're looking at, which are open to interpretation. And then, you know, if we do confirm that life has never existed and doesn't exist on Mars, that then what happens to Mars? You know, like what do we do with Mars that people might see as this resource to be exploited? And that's a real ethical question because you can already kind of see that now, not to get too political about it, but there are already people who are very rich and with resources that do want to go there, and they're not necessarily working in collaboration with the scientists that are interested in the questions around extinct or previous life on Mars. And then the other thing that kind of I hadn't thought about as well that you mentioned is that, you know, what do we do as humanity if we get some, or at least we can't, we figure out that we can't, or we're never going to be able to answer the question if life is out there. And do we have this, do we have you know, a moral duty to then make sure life continues to exist? And you know, for the purpose kind of this, you know, the generalists that are watching this chat, we know that the sun will die. The sun is about halfway through its life. It will live for another 4 point, what is it, billion years, which is a long time, but it's not a long time in the history of the universe, not really. So when that happens, the sun will basically run out of fuel. It will expand into what we call a red giant star. And the size of that star will be just beyond the orbit of the Earth. The Earth will be consumed by the star. So if humanity manages to keep itself alive for another 4.8 billion years, it doesn't really matter. Extinction will have started long, long before that as the sun kind of runs out of fuel. So if we do want humanity to continue, well, we need to get off the planet. If we want life to continue and we're not able to get off the planet, then as you say, should we like have a moral duty to ensure that happens? And I don't know the answer to that question. I have a feeling that we shouldn't, and I don't know why. Because if we're the only life and we are, made extinct, then the universe, I suppose I have this view that the universe will exist even without us in it. So is it important for the universe to have life in it? I don't know. And I don't know the answer to that. So I don't know if you have thoughts on that.
Interesting. Yeah. I think the universe probably doesn't care. Uh, but maybe life, at least I would say conscious life would care. But of course, only if it exists. If it doesn't exist, it won't care. Um, and so does that mean that we today have some kind of moral imperative to work in the direction of spreading life or human life outside our planet? I personally think this is a really hard question, and I don't have a good answer to it. But I think it's worth thinking more about. As you say, we have a long time. Of course, the Earth will become uninhabitable long before the Earth, long before the sun
Mm-hmm.
totally runs out of fuel. But
Mm-hmm.
it's still a long time, so we have some time to think about it. Uh,
Mm-hmm.
Contrary to some other questions that are much more um, close to home.
Mm-hmm.
Um, so yeah, we have time to think about it, but it's an interesting question. But the question about that you mentioned before about Mars and the fact that there are plans to send people to Mars to colonize Mars, that's of course also a bit into the future, not that far,
Mm-hmm.
but we are not as close to that as I think some people think. Uh, but sure, it will probably happen sometime. And as you pointed out, it's not necessarily the case that the people who push this agenda the most have the same um, aims and the same concerns as the scientists.
Mm-hmm.
At the moment, for instance, there are some fairly rigid guidelines about decontamination and orbital bias, and when
Mm-hmm.
you send things to, for instance, to and around Mars and other planets and certain moons in our solar system, but they are not legally binding,
Mm-hmm.
and it may be that depending on who has the most influence when it comes to sending people to Mars, it may be that these rules will not be as well respected,
Mm-hmm.
which would be really sad because it could destroy maybe the only chance we have of finding life in our solar system.
Yeah, I think I agree with you there. I think we need to be very careful that, anything that we do in terms of, in situ and human exploration of other bodies in our solar system, we have to make sure that any discovery is a robust discovery. And if there's a lax regulations about who and what can go to Mars, then we may kind of contaminate any discovery that might be made on the top of contaminating the solar system as well, which I suppose we've already done because we do have a lot of stuff floating about out there. Sometimes it's destroyed, sometimes it's not. So we still have some defunct telescopes floating about that it's safer to leave them where they are than to throw them into the atmosphere, where again it can contribute to pollution of the atmosphere as well. But yeah, I think that if we want to do it, we need to do it well, and we need to do it correctly, and we need to do it robustly. And yeah, I have a worry that when it happens, and I agree with you, I think it will. I don't know if it'll happen now in my lifetime. I would have taken a bet that it would, but I'm not so sure now. I'm getting on a bit, and it still hasn't happened, and we still haven't been back to the moon, which is kind of, you know, the next first step again. But I think when it happens, it needs to be done very, very carefully, and I worry that might not happen. To kind of to finish our chat, I don't know if you want to take kind of the final thoughts or remarks based on what we've just chatted about here. Is there any final thoughts that come to mind?
Well, I mean, there are lots of big questions here. So I don't know. One thing that maybe fitting is to point at astrobiology as being an inherently interdisciplinary field. Astrobiology is a very good, I think, paradigmatic example of a field that you cannot do with only one disciplinary specialty. You have to do it together. And that means chemists and physicists and geologists, but also people like philosophers. And not just in separate in their own little worlds, but together, because the questions are so entangled that it's basically impossible to do it without involving all these different disciplines constantly, which I think is one of the things that I find most intriguing with astrobiology.
Yeah, I definitely agree with you there. And I have to say that, you know, talking to young people, they're really interested in these interdisciplinary topics and questions. It's interesting that well, I would say fewer young people are interested in these pure siloed subjects anymore. They're much more interested in kind of more interdisciplinary, big picture disciplines that allow them to study and consider a lot of different things that they've done, you know, they've learned in school and learned through university. So I think one prediction I do have is that astrobiology as a discipline will continue to grow because we've so many young people are just really interested in it and really want to study it and become part of one of these, you know, big interdisciplinary teams looking at a lot of the big questions. Erik, I think thank you very much for your reflection. I really enjoyed our little chat that we had, and certainly you've made me think a lot. I have loads of questions here that I'll still have a little bit of a think about. So thank you so much for kind of giving your reflections on kind of the talk that I will admit was very much the empirical point of view. And I hope that, you know, the people that are watching this in reflection of the talk also have enjoyed hearing your thoughts as well. So thank you very much, Erik.
Thanks a lot for inviting me. I enjoyed this chat very much too. Thanks a lot.